Hello and welcome to the Let's Talk Azure podcast with your hosts, Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Microsoft 365 focused IT security professionals. It's episode 11 of season 4. Alan and I recently had a discussion about Azure Chaos Studio, an Azure hosted service to help you build resilient and fault tolerant services on Azure. Here are a few things that we covered. What is chaos engineering and why it may be beneficial to your organization? What is Chaos Studio and how it supports chaos engineering? What operations are supported within Chaos Studio? And what scenarios would you use Chaos Studio for? We've noticed that a large number of you aren't subscribed. If you do enjoy our podcast, please do consider subscribing. It would mean a lot for for you to show your support to the show. It's a really great episode, so without further delay, let's get started. Hey Alan, how are you doing?
Hey Sam, not doing too bad. How are you?
Yeah, good, thank you. Are you ready to talk about some chaos, potentially?
Yeah, it sounds interesting.
Sounds scary.
Yeah. Okay. So Sam, what is Chaos Studio useful?
Okay, yeah. So let's probably take one step back before we specifically talk about Chaos Studio and talk about sort of the wider field of chaos engineering. Now, I, I'd probably assume that most organizations wouldn't want chaos anywhere near their workloads in Azure, which is, it's quite a potentially scary name for this sort of topic of engineering. But what we're really trying to do is we're really trying to protect against downtimes and faults within the sort of the stacks of our applications. You know, we sort of shift a lot of responsibility onto cloud providers, to manage everything all the way up to potentially even the software layer, right? We would just we purchase compute or we purchase some sort of PaaS solution or even SaaS solution. A lot of the time we don't really think about what's really happening under the hood, and a lot of the time we don't really need to care about that at all. But there are scenarios, power outages, network connections being cut, software configuration issues, botched deployments. These things do happen, and touch wood, they've happened very infrequently. But when they do happen, there is, there's a direct impact on, the service that you could potentially provide inside of Azure, and your customers being able to access your service. And for your business, that could be lost revenue, lost reputation. There could be an overhead in terms of support around that time. There could be an influx of tickets and things like that. So, if we are an organization that is hosting and running an application that's used by even internally to the business or to customers, there needs to be an element of planning around fault tolerance. And in the cloud, when we architect these solutions, we do spend time to make sure they're highly available, fault tolerant, and in the case of a disaster, having a disaster recovery plan to sort of get started again after one of those events. And what chaos engineering attempts to do is to apply these elements of chaos. This is outages, systems not working correctly, and it's there to try and automate and simulate those happening. But instead of, let's say, we've talked previously on other episodes around load testing, sending a lot of traffic to to one of your endpoints to see what will happen to sort of overwhelm that. What we're really trying to stress here is maybe other products and services that you rely on. Let's say that your application backs off to a SQL server that's running on a Windows Server VM, as an example. What happens if that server's CPU usage hits 100%? Let's say it gets overwhelmed. Maybe you've got an overnight antivirus scan or something like that kicks in and adds a load of load that isn't specifically application load to the box. How do you account for those types of scenarios? So really, what chaos engineering is to try and apply those principles continuously. So instead of you manually, logging into the server and running some sort of stress test on it manually to see how it works, chaos engineering is around having frameworks and experiments in place where you can run these either semi or fully autonomously, maybe even on a schedule as well, and we can talk about that. So really what we're trying to do is we're trying to quote unquote break certain components of your technology stack in a controlled manner, if you can call it that, to look at the knock-on effects of these changes happening in your environment. And what we're really trying to see there is we're trying to test a hypothesis that we might have. Let's say our hypothesis is that if we can't access our key vault to manage our secrets, then we will attempt to access a second key vault in a different region, as an example. Let's say we've put a bunch of engineering work in to make that, highly available. Let's actually test that and try to replicate some of those scenarios.
Okay, so chaos engineering kind of sounds like, in effect, controlled chaos within your application, within your environment, to kind of test or prove out some of your sort of business continuity, disaster recovery plans for things that aren't necessarily to do with your application, but might be external factors to it. So like you said, load testing that we talked about, I think last season, was around load on your application, and you're talking about sort of other outages, other external factors in effect, where you need to test them out in effect without doing it automatically, potentially some of that, or semi-automatically at least, rather than manually going in and changing firewall rules or changing configuration manually, and then I guess potentially leaving some of that left on unintentionally, sort of thing.
Yeah, well, we adopt as much automation as possible, right? Now for deploying infrastructure, deploying code, DevOps, continuous integration practices are really there. And what chaos engineering is attempting to do is to apply this fault testing in the same types of manner with with an overarching solution and technology to help you automate those processes.
Okay, so how is Chaos Studio designed to help support chaos engineering?
Okay, so you've got chaos engineering as its own sort of subsection of quality assurance and testing, and there's many different like processes and architecture and planning and design that you need to do there. Because you really need to think about your application, how it's bespokely designed and architected. So you really need to think about what it is you're trying to test and what are your hypotheses around areas that you think may or may not be fault tolerant. Maybe you've got particular business processes or flows in your applications that are highly critical. Maybe some areas have higher criticality than others. It's those types of decisions where you're going to try to prioritize which areas that you attempt to validate first. And what's really great about Chaos Studio is that they've really built a process and a solution around the major stages of getting from like sort of idea to actual test. So what you really do is you effectively build experiments inside of Chaos Studio, and that effectively describes the test cases that you're going to go through. Um, so what it's really is that you have steps inside of an experiment, because an experiment might not just be one singular thing. You might not just be testing, oh, I can't access my database anymore, as a very simple example. Your test cases might be, okay, we're going to lose access to both the database and our key vaults at the same time, or we're going to try and turn each one of those off in a different order, to see how long it takes things to fail over, and X, Y, and Z. And then you effectively have inside a step, steps run sort of chronologically and sequentially. So you've got step 1, step 2, step 3. And then inside of there you have branches, which are effectively, they run at the same time. They're concurrent, so you can do two things at once, basically. And then what you do is in each, let's say in a really simple example, you've got one step with one branch. You describe a fault that is going to happen there. So as an example, a fault might be a CPU pressure fault, where you effectively say, okay, I want you to pin the CPU on this machine at 99% for 10 minutes, as an example. And then what you would do is then you would have like a filter which describes which like virtual machines that would apply to. Because it might be that you actually want to apply that to multiple virtual machines at the same time. Maybe you've got a scale set, for instance, and you want to apply it to all those virtual machines in that scale set. Because what you might be trying to do there is you might be trying to trigger an auto scaling event, right? You might have a scale set where you say, once I've got high CPU load for 5 minutes, I'm going to add another instance to the set. And what that would mean is that you're, in theory, in this I say very simple example. In this example that I'm giving you, you might expect after 5 minutes for your application to come back, because you might say, okay, well, it's going to take 5 minutes for that that extra instance to be added, and you can actually log the amount of time it takes for your application to become available again. So there's sort of two types of I've talked about faults that you can apply down in those branches, but you can also do time delays as well inside of those branches. So you can say, like, I want to pin the CPU, I want to wait 5 minutes, then I want to do something X, Y, and Z. And probably what is worth talking about the faults that I've sort of started to describe is that you can actually be destructive with those faults. So, for instance, one of the faults that you can actually use is, and there's a huge fault library, and I'll talk about some of the coolest, the ones I think are the coolest anyway. But for example, you can get there's a fault where you can kill a service on a machine. You can just stop that service, to actually, replicate a service dying on that machine. Now, let's say that service that you're going to try to kill on that box is your web server, as an example, or maybe it's your cache, your in-memory cache or something like that. In theory, you could potentially lose anything that's in memory at that time flowing through that that service, right? So there are elements of even potential, not even temporary destruction, like what happens if we kill the web server? Does it start again automatically after, a few moments? Maybe you have to put something in place on the box to make sure that would actually happen. But you do have to be a little bit careful, because you could potentially take that a bit too far, because if you are running this on potentially a production system with live customer data coming through there, you could have potential issues. Other things are like to add latency to specific calls, to look at your user experience and how that operates. I know a lot of web applications that utilize user metric insights to flag. So what they'll use is things like JavaScript libraries to detect the latency between the browser and the web server. To actually look at the response times, and they'll trigger alerts even from effectively end user data. So if you injected 5 seconds of latency overnight, the teams arriving in the morning, would they have alerts in their dashboards to actually show that, that latency and that bad user experience? Those are the type, there's loads of other, there's billions of different combinations of things you can test. But really what you're trying to do is you're trying to preserve that user experience. And by, putting these faults into your system, you can actually see that happening. It's probably worth mentioning as well, a lot of these faults can reverse their impact. Well, they do reverse their impact automatically. So, if you're applying 99% CPU load after 10 minutes, it'll stop that stress test and it'll go back to normal at that point.
Wow. Okay. So that sounds very, that's a lot there. So it gives you the ability to sort of, build test plans in effect to do some of that potential disruption within your application, and some of it can be disruptive if it's things like taking down a service that memory. But like you said, you can then test whether the service comes back or how bad the service is after that outage, as well as, I guess, if you've built in any any automation around making sure services are up, maybe with Azure Monitor or something for alerts, things like that, you can see if that has triggered and self-remediated where it can. So, and without you going onto the box and doing that yourself.
Because you might have like somebody that's on duty, right? And they get the they get an alert. Maybe they get an SMS alert, when the service is down. Has when was the last time we actually tested if that worked? Let's say your service has never gone down since the time you put it live, right? Those are the types of things that you actually want to test potentially in the real world.
Yeah, so you're also talking about testing process as well there then, to see if they actually get alerts and whether the people get woken up on call and things like that to test it, sort of thing.
Yeah,
so
you might not want to test that one specifically too many times, but yes, 100%, because that might form part of your service level agreement with your customers.
True.
You may have a a response time clause, from a user report, and those types of automated metrics, from analytics, really can get you ahead of those customer support queries, effectively giving you extra time potentially on your SLA because you might not have been notified about it. You may even resolve something ahead of time without a customer even knowing about it. So that's why making sure these systems are in place and actually testing that they are actually fully functional is really important.
Okay, cool. So how do you set up the testing? Is it quite easy?
Yeah, so you effectively set up these experiments and these tasks and these faults. You can describe them as JSON, so they can be exported, imported. I believe there's also a REST API for managing all of that as well. I haven't checked for Terraform, but it is just part of ARM REST API, so I'm guessing you could just, AZ API it anyway. It's probably worth talking about what is supported in Chaos Studio. So, Redis cache is supported. Domain names are supported. Virtual machines and virtual machine scale sets are supported. There is a Windows and I believe a Linux. I haven't tested the Linux agent, but there's good support for popular operating systems on both Windows and Linux, and and that's what really gets you that on on instance actual messing around with services, stress testing, things like that. What else is there? There is Kubernetes clusters. So there's a service chaos mesh that's supported. There's Cosmos DB database accounts that are supported. Auto scale settings you can actually change as well, so you can sort of add faults in around disabling scaling and things like that. Key vaults are supported, network security groups are supported, and also app services as well are supported. Just probably talking about some of my sort of most favorite faults that you can add in. So I talked about CPU pressure, physical and virtual memory pressure. You can also put into a virtual machine as well. Disk I/O pressure on both Windows and Linux is supported. You can do a stress NG, actual stress test on the box as well. Stopping services, changing the time and date on a box, which could be kind of nasty. DNS failures, so that's where it hooks into Azure DNS to effectively mimic a bad DNS. Network latency, disconnecting network connections as well, introducing packet loss to a network connection. You can also hook into Azure Resource Manager to do machine shutdowns as well. There's a fault tolerance for Cosmos DB failover. So effectively forcing Cosmos DB to fail over to another region, maybe potentially in a read-only region, to see how your application would be affected by moving over to a read-only region. There's a bunch of different tests for Kubernetes service. That's not really a area that I play in, but there is a bunch of different networking and pod faults, stress faults, time and HTTP and things like that. Rebooting Azure cache, Redis cache is in there. Setting specific security group, network security group rules on the fly is a fault that you can do. So like deny maybe and things like that. Key vault, there's a bunch. Deny access, disable specific certificates, and then you can stop app services as well. There's also a fault for disabling auto scaling as well. There's a bunch of different things that you can, I'll call play around / mess around with in an automated fashion. Yeah, sorry, Alan, you were going to say something.
I was going to say, was that just a few? Was it? Because that's quite a few there, and they all sound quite disruptive to a service.
Yeah,
definitely.
well, I basically went for the full list in the end because every time I read through it, I just get more excited about all the different things I could potentially do to a system. It's quite, and what's interesting is that you can. It's not just one thing that you can do. You can also branch these together, build them into plans, and run through like multiple of these things sort of over and over. There's a lot that I could just think of this completely horrible test plan that you could basically run on your system to see what it does. And just to probably talk about how you actually do it, you sort of onboard specific resources as targets, and I believe what that does is it sort of adds like a sub resource to that resource to say that it's like available for chaos. So you sort of opt in each of your resources for chaos, and then you can effectively target them in your experiments once you've sort of onboarded each one. I believe that's so it can like deploy the agents and make sure that like not everything is just opted in for chaos, from sort of day dot basically.
Yeah, so you have to have permission to the resource to add it into a chaos studio kind of thing. Yeah. So you can't just have start adding other teams apps or services into it.
Yeah, exactly. And it's probably worth talking about is that in its most default sort of setup, what you're talking to needs to be able to talk back to the chaos service. So you do need to think about networking and how this could hook into those resources. And probably just to call out as well, this is only Azure only resources at this moment in time. It's all the same tenant, but you can sort of span across multiple subscriptions in your tenant. So it's not like you have to have chaos experiments segregated by subscription. You could potentially have a chaos subscription and sort of connect to everything from there.
Okay, cool.
Would that be one of your spokes, Alan? Could you imagine having a conversation about adding a chaos spoke?
Yes, I could see that. I don't know if that'd be anytime soon for me, but yeah. Okay, so what kind of on the same sort of wavelength, of path of talking, what environments would you use chaos testing in? You kind of talked about potentially maybe testing on production and some other ones, but what environment would you use?
Yeah, so I think it's probably worth talking about sort of shift right and shift left, thinking here, right? Because if you approach it from a shift left sort of starting point, which is probably where I'd say a lot of people would start from, and that is really going to your development environments, right? So your staging, your pre-prod, whatever you call your pre-release environment. Some people have mirrors of their production environments with sanitized data in them, that very well mimic what's going on in their production environments. Other people might just have one development environment and a production environment. So it makes sense to start at least testing and looking at the sort of the efficacy of chaos engineering for your organization in those development and test environments. And I suppose that's probably the right time to call out that this is a discipline. It's something that you're going to have to embrace and to invest time in and things like that, right? It's to me it's an element of risk reduction and quality of life improvement for sure, but you do have to balance that with the amount of time it takes to set up these environments and these tests. Now, I think Chaos Studio does a really good job of that because it's highly integrated with these Azure services. And if your apps do utilize the services that I described and some of those faults make sense to you, but it also might be that you don't use different things. You might have things that are outside of the feature set at the moment. So you have to think about that, but it is helping you to effectively connect to these resources without you having to do it manually, or to build your own sort of hooks and test runners. If you then think about a more of a shift right responsibility in testing, that's potentially actually running chaos experiments in production. Now that does sound scary. It's somebody that has potentially has ultimate responsibility of making sure that the customer's experience is maintained. Doing a key vault block Monday morning at 10 o'clock might not be the best idea in your B2B app, right? Because that doesn't sound like a good idea. But there is a deployment that has to happen between staging and production. Staging and production environments are usually highly segregated, and some of them are set up by hand completely separately, and sort of attestation of those environments, verifying, that they are functioning correctly, is also really paramount to the running of the service. So it may be that what you do is you schedule some, a maintenance period, and you communicate that to your customers, and you say, on Sunday morning at 3 o'clock in the morning. Oh, I don't want to be the person that has to wake up and do those tests, right? But that you're going to run a set of chaos experiments, to actually ensure that it's fault tolerant, and then when somebody cuts through the cable, at a data center. I know it's not that simplistic anymore, but somebody cuts through the cable at the data center, and an availability zone goes down, that that potentially your app is going to fail over in those scenarios, which in turn is going to make sure that you don't get those support calls at 6 a.m. on a Sunday morning, right? Because nobody wants people that are unhappy, and it's a potential risk to the business.
Yeah, definitely. So it definitely sounds interesting to test it on production. Like you said, you won't be able to do it potentially in the daytime, not without informing customers, things like that, to prove out that, like you said, that the environment has been configured as expected, and that any of the failovers, etc., are all in place. So it does make sense. But like you said, most people will probably start with the left side, where they've got a staging environment which is identical or close to infrastructure wise and app wise, and testing there to probably be a bit more disruptive, or bring more chaos to that environment, to stress, in effect, stress test it in other ways before maybe doing a lighter weight version, maybe on production, where you don't take it out completely. It might be, or it is the same. I guess you prove out on the staging first, and then maybe prove out on your production.
Yeah, definitely. Yeah, like you would with any system that new piece of software, new code, new processes. You would always go through those different stages towards the right, and testing as you go and validating, right? So yeah, and some organizations may do a hard stop of, we do manual checking of production to make sure it's correctly configured. Any automated tooling stops it staging or pre-prod environments, and that's at least going to be better than not doing anything at all, as a first step for sure. So yeah. So for me, I think it's somebody that's built highly available systems and actually validating that they work. I've worked on projects where there's been events that have launched at specific times, and leading up to that, if you're inviting tens of thousands of people to an online event, the organisers of that event will spend a lot of time and money to validate that when that event happens, there's absolutely minimal technical risk as possible. Because, in touch wood, this doesn't happen, but you can sort of, bet your left arm that on that day there'll be an outage somewhere, or something weird will happen on that day. You'll have prepped for it, you'll have scaled your instances, and you'd have thought about every single thing 5 times, and then something completely outside of your control. And that's not really I don't really want to say that in a scaremongering way, that always happens, but it's sort of when you least expect it. So that's why highly durable systems, highly available systems are really important in those scenarios.
Yep, and they need to be, like you said, they need to be tested. Okay, so how do you chaos test private resources and networks?
Okay, so for sort of the most sort of basic resources that would be inside of a virtual network, you do need to set up the ability for those resources to communicate with the Chaos Studio service. Now, there are a couple of caveats, so you need to think about that, but especially if you've got private internal applications. Maybe you've got applications that aren't, I say public facing. Well, yeah, completely public facing, completely isolated apps in virtual networks. But then also, what you generally tend to have is some sort of layered network security approach, where your end resources, even to a publicly available service, are completely private, right? You'd have your routing set up that it can only go one way and things like that. So you do need to think about that, because you might need to adjust some of that networking to make this a possibility. And it could be time limited changes. whilst you're experimenting, and then revert back to your other state. I mean, then other people could say that you're modifying your systems. But anyway, you need some network access into it. But there is also virtual network injection for Azure Kubernetes Service and Azure Key Vault that are running within virtual networks. So in theory, you can use virtual network injection to get to allow Chaos Studio access to those virtual network environments. I haven't actually tested that, but effectively it will help you to bridge in and inject into those environments sort of in real time.
Okay, cool. That sounds good. So yeah, it's like with other resources within Azure, you need to be able to talk to the service itself to be able to do that. Here's a random question. We were talking about that it's Azure only, but does it work with Azure Arc?
I haven't tested that, and I haven't seen that on my travels. Is what I'm going to say for Azure Arc, but in theory, I don't see why that wouldn't work.
Yeah, I guess it's just their deployment mechanism in it via Arc that might not be in place yet. I know it's kind of the same thing, but it's a slightly different agent or different mechanism than on native Azure, isn't it? So
yeah, and I suppose it's probably the right time to call out as well. We'd usually talk pricing and availability towards the end, but Chaos Studio is currently in preview. No official pricing as of today, so it could well be. It's one of those services that's not that new. It's been in preview for quite a long time. No criticism at all, but that just sometimes happens in Azure. But yeah, we don't have any official word on pricing, SKUs, and all they've effectively said is that it will be some sort of consumption based billing. But we don't have an SLA at the moment. We don't have pricing, and my assumption is the development of the products will be rapid and iterated on, right? So that's probably just worth calling out at this time.
Yeah. Okay. Cool. So it's in preview. So there's potential for it to maybe work in the future if that's a requirement, I guess. Okay. So how does Chaos Studio sort of integrate with Azure?
So it's probably worth describing automating experiments at this point. And what you can do is you can effectively use a logic app to automate experiments. And what you do is in that logic app, you'd set up like a timer trigger for that logic app. So let's say you wanted to add some chaos every day. I mean, that might be a bit scary, but you can automate these tests. What you can do is you can run a resource manager action against the reference of the actual test plan itself, or the experiment itself, and then get it to trigger automatically. So the experiments are resources themselves that have their own actions that can effectively be triggered. So really, it's completely baked into the underlying architecture of Azure, right? There is a REST API. You can access it from the ARM API, so it's highly integrated and built in just as another resource. So it feels a lot more connected than maybe other things, if that makes sense. If that's probably the right way of describing it, because we sometimes see where there's other solutions that are in Azure that maybe don't have the great, really, what's the best way of describing it? Really well connected, like a bolt into Azure, if that makes sense, right?
Yeah,
sometimes it's hard.
They have their
automate.
own. Yeah, some services have their own APIs, don't they? That sit on top of it, where you're saying this is, in effect the Azure Resource Manager native. You can call, start triggering things like that.
Yeah, exactly. Yeah, so it's basically really highly integrated, which is a real bonus for sure.
Okay, cool. So, is there anything else that you've missed or you want to bring up? around Chaos Studio?
I don't think so. I think that's pretty much it. I've been sort of testing it, playing around with it. Um, I've verified that you can. Not that we really needed to verify that their documentation was correct, but I've verified that you can stop service. You can install the agent on virtual machines. You can get it to stop services, and then I did some sort of testing around key vaults as well to see how, because key vaults is an area where there's no real high availability built in, is that there's no failover with key vaults, right? So a lot of high availability sort of process and logic around key vaults is kind of baked into the business processes, in sort of certain apps. Attempting to connect to a key vault, maybe retrying a few times, and then if you can't get it, going to another place, and then you've got to think about how you synchronize your key vaults and all of those different things. So those two areas were really important to me, because a lot of the time when you have sort of virtual machines on infrastructure as a service, a lot of the actual services and a load of those machines can be the actual issue. Like, I've had loads of virtual machines that have gone to 100% for no reason and things like that. It's just not so much nowadays because I don't really tend to deploy in those environments, but I've seen it quite a lot, especially with things like burstable instances. So it's those types of tests that you really want to try to automate. And I'm inherently lazy, so I love to automate things. So when I can do that, I'm just not sure if you were to go through like a customer's change process about talking about chaos engineering, how that would potentially go down. But that's probably when I feel a little bit braver, that's what we'll have to start having the conversation about.
Controlled chaos. It's controlled chaos.
Well, I think as well, because of Chaos Studio is currently in preview, it's like a double whammy at the moment, right? The name's scary enough as it is. You then label on a public preview, and it's maybe a bit too much at the moment. But really great tool. It's got some really, to me, applicable real world use cases, and those are the types of systems that I really get excited about.
Cool. Okay. So I think I talked about the Azure load testing that we did last season. I think it was episode 17 of season 3, and I think that kind of definitely ties in with this, because it's talking about load on your application itself. So it's definitely worth checking that out.
That's all around quality assurance, UAT. Testing and high availability. So check that episode out, because there's some, again, really good tooling for load testing in Azure. So Alan, cool. Next episode, that's one for you. So what are you going to cover?
Yeah, so I'm going to cover, because I don't think we've done it yet actually, is talk about Microsoft Defender for Cloud Apps, Microsoft CASB, and software as a service, security posture management.
I cannot believe we haven't done Defender for Cloud Apps yet.
Yeah, yeah,
such
definitely
a big
not
part
in the
of
new
day-to-day, right?
Yeah, it's I don't think I've seen it. I have to double check again, but I've seen it since we not re-engineered, but brought the podcast back to life in our new format.
Yeah.
So definitely one to go through and talk about all its benefits and things like that.
Yeah, no, it'd be a great episode.
Cool. Okay, so did you enjoy this episode? If so, please do consider leaving us a review on Apple or Spotify. This really helps us reach more people like you. If you have any specific feedback or suggestions, we have a link to it in our show notes to get in contact with us.
If you've made it this far, thank you very much for listening, and we'll catch you on the next one.
Yeah, thanks all.